In this video, we will prove that every Hilbert space H has an orthonormal basis, and we will use Zorn's lemma to prove this one. Now, what is Zorn's lemma? Zorn's lemma is if S is any non-empty partially ordered set in which every chain has an upper bound, then the set has a maximal element. So, you have a lot of chain and each chain has an upper bound, then the set S has a maximal element. And we will use this one to prove the theorem. Now, if H is any non-zero vector which is in the Hilbert space H, then if we divide H by its norm, then it becomes unit vector and it's orthonormal. Now, if we consider F be the family of all orthonormal set which are subset of H, and consider this chain, so where F1 is subset of F2 and F2 is subset of F3, and it keeps going on, where each Fi is in F, the family of orthonormal sets, so each Fi is orthonormal. Now, if we take all of their union, then this would be an upper bound for this chain. Now, by Zorn's lemma, there is a maximal element. So F has a maximal element and we call it B. And since each are orthonormal, so the union should be orthonormal. So B is orthonormal by the definition of F. Now, if span of B is denoted closure of span of B, so this is closure of the span of B. Now, we want to prove that, we want to show that this one equals to H. So we will prove it by contradiction. So suppose span of closure of B is not equals to H, so this is not equals to H, then by orthonormal decomposition, the Hilbert space H can be written as this one and direct sum of its orthogonal complement. So this one and direct sum of its orthogonal complement. Since we assume this one is not H, so this should be non-empty. This should be non-empty. So there exists a vector y in here with y is non-zero vector, and since y is orthogonal complement of span of B, closure of span of B, so y should be orthogonal to B, where B is element of closure of span of B. So those are orthogonal. Now, since y is non-zero, then B union the unit vector of y should be in F, but we already assume that B is the maximal element, B has a maximal element, but now we have another element contradicting the maximality of B. So this one should be 0. This should be 0 vector. And span of closure of B should be H. This completes the proof. So every Hilbert space H has an orthonormal basis. It's little complicated, but if you think you will understand. It needs some time, but you will understand. Thank you for watching.